This is quiz 3, question 1. Project evaluation question. We're going to have a local movie theater that closed. We decide that we want to open a laser tag. We have some estimates of expenses. We have some capital expenditure and then some depreciation. We also have potentially this revenue source where we have local teens that want to come play. That's going to be our only revenue source. We make some assumption about how many of those we can quote unquote capture. And then we believe that in year 1 we have a certain percent we can capture, etc. We have some rate that we can charge per game. And then I'm going to sell at the end of year 3. And I have some note about the timing of the sale. We have a discount rate, a tax rate, and we go from there. Okay, so the first thing that we want to do is try to figure out what the revenue is. And we start from 0, 1, 2, 3, and 4. And we have some assumption about how many teens we have. Let's see. 2%, 5%, 5%, and 8%. And local teens. Let's say there are 1,000 of them. We know that we will get, let's see, where does it say it? $50 a game, and you expect each team to play one game per month. So the revenue per game is 50. Games per month is 1. So we have no revenue because we capture 0% here. You can put that. It doesn't really matter. Oop, let me let go of Siri. Hush, Siri. Okay, so 0% times the number of local teens times the revenue per game times the games per month times 12, because there's 12 months in a year. I want to lock this, I want to lock this, and I want to lock that. Boom. Okay, now our expenses. Lease expense of $150,000 starting in year 0. I'm going to bold, oops. I'm going to bold that. Equipment purchases of $100,000 in year 1, and these are not considered CapEx, so they only last for 1 year. Staff expenses of $150,000 for year 1, $300,000 in 2 and 3, and $500,000 for year 4. Okay, I've already forgotten those numbers. $150,000, $300,000, $500,000. Okay. We have CapEx of $100,000 in year 0 and $20,000 thereafter. We're going to put it down here. And again, the reason for this is that, hold on, let me just, the reason for putting the CapEx expenditures below the line is because you are not including that in your tax calculation. So we will want, this is staffing, we will want to include our CapEx as a cash flow change, but it doesn't change our tax calculation. So the goal of this up here is to calculate our taxes, and the goal of the bottom part is to calculate the actual free cash flow. So this is all accounting information, and this is actual cash flow. Okay, so I believe that those are all of the expenses. And this will give us EBITDA. Okay. Capital expenditures will be depreciated each year on a straight line basis over the following 10 years. So let me move these down a little bit. I'll just write it out. Year 0. There's no depreciation starting the first year, but the depreciation will be $10,000 going forward. It lasts for 10 years. It goes to 0. Depreciation from year 1 does not start until year 2, and it's going to be this divided by 10. And notice that there is no depreciation from year 4, and that's because it starts in year 5, and we're only going to go out to year 4. So total, yeah, sure, I'll make it capital. Total depreciation is going to be the sum of all of these things. I'll drag it across. Ooh, but it's not in the right format. Let's add a border on the bottom. Okay, so now we have total depreciation. Actually, let's just call that depreciation so it's easier to see. Once we have EBITDA, we can calculate EBIT. Taxes, we have our tax rate. %, and the discount rate is 10%. So 0.2 and R is 0.1. All right, so post-tax, we are going to get, now these numbers are all red. There would be a slightly different accounting rule, like your accountant would have all this stuff figured out. But for our purposes, and also we only chose 1,000 teens here. In the real world, there are going to be more than that. So let's pretend there are 20,000. All right, and then let's look at our sale price. So in this case, we have, let's see, where does it say that we're going to sell it? You're going to sell the project at the end of year 3 based on the expected value of the perpetuity of cash flow from year 4 onwards. So we're going to assume that cash flows grow at 4% per year, and we want to look at the free cash flow from there. Okay, so let's put somewhere over here, the growth rate is going to be 0.04, and we need to capture the free cash flow. And somewhere in here, so let's say this is the cash flow for year 4, there's going to be a sale price. Okay, so our post-tax income is going to be this line. And just so we're clear, this is the free cash flow calculation. Okay, so we need to add in depreciation because we subtracted it. we need to subtract CapEx. We don't have any assumption about working capital, so our free cash flow should be that plus depreciation minus CapEx. Let me add a fancy little bottom line there. Okay, so we're going to sell here, and it's going to be a perpetuity. This is R. This is G. That would be our sale price. So we don't have to worry about column 4 anymore. So total cash flow is going to be and let's delete that. Make it look pretty. Okay, so the PV of this cash flow is going to be that divided by 1 plus, nope, not tax rate, discount rate to the power of whatever year it is. And PV is going to be the sum of those things. Okay, and the question says, how big does the local population of teenagers have to be to break even on your laser tag business? So that is a goal seek question. So we want to set the NPV equal to 0 by changing the number of local teens. 17,011 teens, and let's just check this. 17,012 teens. So we got the right answer, and that is exactly how we did it.